In the mid-1990s, Mars was more than a dot in the sky. It was a tantalizing frontier. NASA's success with Viking in the 1970s had taught us much about Martian weather and soil chemistry, but questions about water, climate history, and the possibility of past life remained. In 1996, the discovery of possible microfossils in a Martian meteorite reignited public and scientific excitement. Could we send machines to roam Mars's dusty plains and bring back definitive answers? That spark led to the Mars Pathfinder mission, which, in 1997, proved a single small rover, Sojourner, could navigate Martian terrain and relay data over weeks, not hours. Sojourner's successful descent, carried by an airbag-bouncing lander, demonstrated that rovers could survive the harrowing 7 minutes of terror during atmospheric entry, descent, and landing. It was a modest beginning. Sojourner was golf ball sized, moved at 1 centimeter per second, and carried just 7 instruments, but it laid the groundwork for what would follow. In 2003, NASA launched a pair of much larger rovers, Spirit and Opportunity. Each was the size of a golf cart, powered by solar panels, and equipped with panoramic cameras, spectrometers, and rock abrasion tools. They landed nearly 1,000 miles apart, Spirit in Gusev Crater, believed once to have held a lake, and Opportunity on the Meridiani Planum Plain, where hematite, blueberries, hinted at past water. Spirit touched down January 4, 2004. Its first images showed a rocky hillslope framed by distant mountains. Over the next 6 years, Spirit climbed Husband Hill, examined silica-rich deposits, and uncovered layering that spoke of volcanic activity followed by hydrothermal processes, proof that Mars had, at least locally, environments friendly to microbes. Spirit's wheels eventually faltered in soft soil, and after getting stuck in 2009, the rover fell silent in 2010, its mission official at over 20 times its planned lifespan. Opportunity landed 3 weeks later, on January 25, 2004. Within days it had rolled onto the berry-strewn plain and confirmed the sphere's composition as hematite, a mineral that on Earth commonly forms in water. Over the next 15 years, Opportunity traversed more than 28 miles, scaling Victoria Crater's rim, studying exposed strata, and sending back over 217,000 images. Its odyssey ended dramatically in June 2018, when a global dust storm blotted out the sun, its solar panels went dark, and despite months of listening, ground teams never heard its cheerful ping again. Lessons from these twin rovers shaped NASA's next leap, the Mars Science Laboratory mission, featuring Curiosity. Launched in 2011 aboard an Atlas V rocket, Curiosity was LT-Celotron size, 10 times heavier than its predecessors, and carried a car-sized radiation-shielded body packed with 10 science instruments. To land safely in Gale Crater, mission planners devised the ingenious sky crane maneuver. After the heat shields slowed the spacecraft, rockets lowered the rover on tethers, then flew away, leaving Curiosity to touch ground softly. Since its landing on August 5, 2012, Curiosity's ChemCam laser has zapped over 500,000 firehose-like pulses to vaporize rock and measure its composition. It has quantified organic molecules, discovered seasonal methane spikes in the atmosphere, and climbed Mount Sharp's foothills, tracing a timeline from ancient riverbeds and lake sediments to more arid windswept plains. Curiosity's mission, planned for 2 Earth years, remains active into its 11th, thanks to robust design and nuclear-powered longevity. Most recently, NASA's Perseverance landed February 18, 2021, in Jezero Crater, a dried river delta teeming with clay-rich deposits. Perseverance carries 7 instruments, a drill to collect core samples destined for eventual return to Earth, the first Mars helicopter, Ingenuity, cameras for high-resolution video and color panoramas, and the Sherlock instrument that can pinpoint organic compounds. Its mission aims to seek biosignatures of ancient life, characterize past environments, and test technologies for future human exploration, like producing oxygen from the Martian atmosphere. Beyond science, each rover has captured public imagination. Millions have watched live-streamed landings. Students worldwide name Opportunity's wheels. Curiosity's self-portraits are shared in classrooms, and Ingenuity's daring flights echoed the Wright brothers' triumph. Mars Rovers have become our robotic ambassadors, teaching us not only about another world's past but about perseverance in the face of unknowns. From Sojourner's 10-week stroll to Perseverance's multi-year quest, the story of the Mars Rovers is one of escalating ambition and ingenuity. Each mission built upon the last, improving landing techniques, mobility, scientific payloads, and reliability. And as Perseverance begins caching its first rock cores, the next chapter prepares to bring Mars's secrets back to Earth, where human scientists will pore over them in laboratories. It's a journey of discovery that began with the golf ball rover and now stands at the cusp of answering one of humanity's greatest questions: are we alone?